Alrighty, y'all. Cool, we're gonna get started in just a minute. I'm just gonna pull some stuff up on Blackboard so that everybody knows where everything is that's coming up. Close things we don't need because Lord knows these computers can't really process a bunch at once, so. Sort of like three-factor authentication. I don't know if other people have this, but not only do I have to type in the number when I use the little app, I also have to use my thumbprint. So it's like really making sure I'm me. Okay, no problem. Yeah, I know that stuff happens and sometimes y'all need to be in Zoom. Yeah. If you change it, that's fine. Yeah. So for those of you just coming in, Emma's been asking some great questions about the project. If after finding your sources in class the other day, you're like, I actually hate this topic, no worries. Even if you've submitted a topic and then you find something else you're more interested, no worries, you can change it, no biggie. And you don't even have to tell me you're changing it if you don't want to. Really, having you all think about the topic now is so that you're not like panicking the week before to the posters too, right? So we're sort of scaffolding. So these are some of the myths and the controversies in psychology. There are a lot more. One of the things we're going to talk about in a couple of weeks is APA put out an apology for how racist they've been. That might be an interesting one to do, right? The torture thing we talked about. But when you're ready to submit it with your resources, you just go in here and you can either upload or you can create submission. Just don't do it in the add comments, because then when I go to grade, basically where the Zoom bar is right now on the right hand side of the screen, that's how tiny it shows me what you submitted. Whereas if you submitted under create submission, I can actually read it. So be kind to my aging eyes. They've been getting worse every year, unfortunately. Yeah. Okay, so yeah, if you're on our Blackboard page, it's under final project poster, which I realize is weird grammar. It should probably be final poster project, but that's all right. There's also a template for the poster that you can use. And this is also where you'll turn in your outline for the poster and the poster itself when we get to those points. So yeah, if you don't like any, you're definitely not beholden to these like 30 topics. You can just Google, like myths in psychology or controversies in psychology. And find there's unfortunately we have been a very controversial field, so there's a lot to draw from, and it's fields that are learning and growing. And I think one of the big differences is that now we are actually getting women and people of color and people who are part of the LGBTQ plus community in leadership positions. And when that happens, it's a lot easier to say, this stuff hasn't been working. Let's do better. And so it's really, representation is important. You'll hear people say that, but it's not lip service. It really is when you get people in your organization who are diverse, are people who have had different experiences, you'll often find you start to see some changes that you might not expect. So yeah, in fact, I believe APA just elected its first ever Indigenous president. She's a female of American Indian descent. That's huge, right? So again, those voices are so important. Yeah, unfortunately, because we haven't had that for a long time, if you Google controversies in psychology, you will see a lot of them, which, yeah. is sad, but also makes it really easy for y'all to find a topic for your poster, fortunately or unfortunately, right? Other questions about the poster? So I had a couple people at the end of class the other day ask me where we turn in the assignment we were working on. And if you go under assignments to where you clicked for the sources for your topic, if you click where it actually says sources for your topic, that's the submission portal for it. So since you made a Google Doc, if you just want to go into create submission and link it, that's fine. Or if you're someone who prefers to copy paste or upload it, that's also fine. And then this weekend, I'm going to try real hard I've been good about doing paper grading, but I need to catch up on my Blackboard grading in all my classes. So I'm going to try to do that this weekend. Although we will be at homecoming because until very recently, my daughter was convinced that we always have bounce houses on campus because she only comes for homecoming. So now she likes to come and see the fossils in Blocker as well. All right, any other questions about logistics for the class? So I believe it is a week from today. Yeah, I'll be giving you your exam 2, and you'll have over fall break and more to complete it. You don't have to do it over fall break. Yeah.
What lessons does it have to be
So this is a good question. You do have to have scholarly sources for the parts where you're like challenging the myth. But you might need to use, a popular source in order to present the myth itself, right? Yeah, because you might not find a scholarly source that's like opposites attract or something like that, right? So yeah, as long as you have whatever it says on your syllabus, I forget if I said 4 or 5 scholarly sources, you can have more than that are not scholarly as well. Emma, did you have something too? Okay, that's okay. If it comes back up, please feel free. Yeah, I think that's it in terms of logistics. Here, I'll pull up the syllabus real quick just so we're all on the same page. And again, remember, you can always find it on Blackboard if you've lost your paper copy. Remember to be doing the perusals. I need to go in and check on scoring to make sure it's working for that because God knows. Yeah.
If we do a controversy, is there a right answer, or you choose a side to like?
You choose a side, basically. Yeah, that's a good question. Yeah, because for some of the controversies, there might not be. But for others, it's going to be obvious. Like, we shouldn't torture people, right? But like, yeah, others will be less obvious. Yeah, that's such a good question. All right, so here is your final project poster outlined in a lot of detail. So you're going to talk about 2 cognitive biases and 2 logical fallacies that relate. That's why we did that assignment last week in groups. 4 articles. So again, 4 scholarly articles, but if you need some popular sources, you can definitely include more than 4 sources. And then here are your steps. And so in theory, in a couple weeks, your outline is due. If you're still struggling to get your topic, really wanting to find one that fits, as with everything else in the class, you can turn it in a little late. And then the rubric that I believe Dr. Martorell developed for us is on the syllabus. All righty. And then looking forward, again, we're going to be talking about numbers for basically between now and fall break. Then we'll be talking about science. We'll talk about statistics charts. And then we'll get more into applications of the stuff we've been learning all semester, sort of around Thanksgiving break. Yes, good question. So for the topic, you do need 2 sources, and you can use the 2 sources you found on Monday. And then for the actual project, you need 4 scholarly sources. And if you want to use more, certainly feel free. But 4 is all I'm requiring, if that makes sense. All righty. So again, today, I don't understand why you signed me out in the 2 seconds I was sitting here, but okay. Google Drive does not like me this semester. Do not know why. All right, so today we're gonna start talking about numbers. So I am gonna hide these captions so we can use the superior Google ones that don't cut off stuff on the slides. There we go. So what I like to start with here, like when you hear or think about numbers, and folks in Zoom can feel free to throw stuff in the chat here as well. What do you think of? What are your feelings when you hear like numbers or statistics? Or just math? I feel like that was maybe more traumatic.
Perspective.
Sure, yeah.
This is that's why I do most of it.
Yeah. So numbers are super important for financial things. Unfortunately, a lot of times in high school, we aren't taught that stuff, right? The applications of it. So like the first time you fill out your taxes, you got to figure that stuff out for yourself. My favorite year, this is with sarcasm, was when I was on my residency. And so half the year I'd been in Ohio, but I was still a Michigan resident then. And then I also had to file Georgia taxes, so 3 states. It was a hot mess. I get sad. Yeah, I think a lot of people get sad or scared. Unfortunately, people have had bad experiences with math, right? Maybe even if you were good at or you're so good at math. So I was someone who was always good at math. They put me in the AP classes. I didn't like doing it, but I could do it, if that makes sense. And then I got to undergrad and I took a statistics class and I was like, oh, this is why we do math. So that we can understand the data that we get. And that finally like opened my eyes for me. And now I actually love doing psych stats. I was doing it last night while my daughter was at her swim lesson and like excited with the data that I'm getting. So this is a sample I collected over the summer. I might have mentioned it before of like trans and non-binary individuals. And I was comparing the people who identified as trans versus the ones who didn't. And even though they all fall under sort of this gender queer, gender non-traditional umbrella, those folks who identify as trans are actually having more issues than the folks who don't. Equally interesting. And again, like very few people probably get geeked out about running AMT tests, but I did. And so we've mentioned some examples, but where are some other examples where we're using numbers, either in psychology or in the real world? Yeah, for sure. It's so true, right? Like, yeah, we might not be using the quadratic formula, but we're forever, like, how long do I have till I'm on empty? Right? You're doing those calculations in your head when you're driving around, right? Or looking at your bank account, right? Fun thing that happened to me yesterday, not fun, was that randomly my power turned off. So I went to report an outage and they were like, oh, you have overdue bills. And I was like, what are you talking about? I didn't get any notices. And they're like, we sent notices. We never got them. So our electricity just got turned off. So as soon as I paid it, it got turned on. But now we're like, are we gonna get our bills? Right? But things like that are really important, right? There are people who come and read your water meter and your electric meter, things along those lines. And so there's lots of different ways that we do encounter numbers in our daily lives. And so this is a little video sort of plugging statistics and why they're important.
So in high school, I never even heard of statistics. And I knew I liked math and I knew I liked science.
In high school, I went to a conservatory for music. I was a viola performance major.
When I started college, I was taking a bunch of math and economics classes. And then in my junior year, I took a probability and statistics class.
I remember sitting there in the classroom thinking, wow, this is a really interesting problem, and he's using statistics and probability theory to try to solve it.
Statistics is amazing because it has many diverse applications, from search results on Google or Bing to recommendations on what you should be shopping for on Amazon.
If you're watching a YouTube video and at the end you get recommendations for other videos, statistics were used to give you those recommendations.
I've seen statistics in ice skating, I've seen statistics in agriculture. I mean, I've seen statistics in climate control. I mean, statistics can actually be anything that you like, anything that you enjoy, anything that you want to do, anything that you're passionate about, you can, take statistics and it fits.
I'm very lucky to get to use statistics to answer some of the questions that I think are the most important questions about social justice and human rights violations. And on my best days, I get to spend the majority of my day doing data analysis to answer questions for the United Nations, to contribute evidence to war crimes trials.
As a part of my PhD, I created a statistical software package, and Google emails me every time someone uses it. And people have used it to analyze DNA and find genes that are related to cancer.
It's even used in the food pyramid. You know what I mean? When we come up with suggestions, of what you should eat and how much of it you should eat, we try those things using statistics.
Statistics is critical for everybody entering the workforce because so much of industry and government and everything today is data-driven.
Just like it's important that we all know how to read, we all need to know statistics.
Look around you. Everywhere you are, there's data, there's information.
Whatever your passions are, statistics will be involved.
We're producing so much data these days. Regardless of the field that you pursue, whether it is astronomy, criminal justice, and medicine, going forward, you've got to know statistics.
And again, this is one of the main reasons why in this particular course, we spend a decent amount of time looking at how do we use and analyze numbers. We're not going to teach you how to run a statistic, but we want you to be able to read an article, look at data, and say, I know what this means, right? If you are interested in statistics, there is a couple different courses you can take. So the math department has both a 200 and a 300 level statistics course. And then we have a stats and methods course within Psych as well. And as they said, this was 2014, like 10 years ago, but still true that being able to interpret statistics and use the information from statistics for, let's say, marketing or things along those lines is a crucial part of today's sort of data-driven world. Alrighty, so let's use this one. The Powerball is always going up and up, and everyone's always buying Powerball tickets or Mega Millions tickets, right? What are your chances of winning the lottery?
1 in 300.
Something like that, right? Yeah, and of course it depends on how many people buy tickets and whatnot, but I think a lot of people think it's much higher, right? Yep, you were really close. So it's 1 in 292 million. There you go. The smaller prizes, obviously, do that. Powerball rules changed in 2015. Before that, it was 1 in 175 million. So basically, it happens, right? Real people win the lottery. One of the grown-up things that my husband and I have been doing the past few years is we need to see a financial plan. And he told us he's had a couple clients win the lottery. So if you ever win the lottery, we rent a limo, we drive up to Richmond, keep you anonymous so people don't harass you. And so, it does happen, but some people unfortunately use this as their savings plan, where they'll I'll just buy lottery tickets and then I'll win and it'll be great. And it can be really problematic, obviously. So this is if you looked at all the tickets people bought for a Mega Millions or a Powerball and just laid them out side by side, that's how much room it would take up across the entire country, basically. That's a lot of tickets, right? And you're gonna pick one, essentially. Or occasionally more than one person has the same number, right? So one of the things we want to look at in psychology, in looking at statistics in general, is what's a good versus a not as good or bad statistic. So when we use statistics, we want them to clarify information for us, clarify the situation. We want it to explain what the data are telling us, simplify what the data are telling us. Instead, we, often get overwhelmed by statistics, and we don't have to. When you look at a statistic, just like when you're reading an article right? Or listening to something on the news or seeing something on TikTok, you should ask yourself, who created it and why? There are, unfortunately, as we've talked about, incidences where people can do what's called key hacking, and key is here referring to whether your results are significant or not. And they can cut data in sort of sketchy ways to try to get significant publishable results. And that's one of the things Brian Lansing did with his data and why a bunch of his stuff got ripped back. So here are some examples. So the rate of homicide of women goes up when they are pregnant. And we're not exactly sure why, other than domestic abusers are awful people, but it could be now some energy is going to be taken away from me onto you, right? We need statistics to understand clinical trials for medications, for the vaccines, right? All these people who claim, oh yeah, all these people got the vaccine and now they're dead, right? Okay, did they die from the vaccine or were they in a car accident, right? So I've been in a couple different clinical trials for flu and COVID vaccines, and they told me like anything that happens to you, you have to report. Like if you did something weird, you gotta tell us and we'll list it as a side effect, right? Even though it might be due to something else. I don't think it was for the vaccine in particular, but a medication trial I ended up not qualifying for. They said if you turn out of our parking lot and get in an accident, we gotta report that. So some of those are weird. You know, car accidents are among the most common reason for fatality in the US. And for years, they were actually the most common for kids. Does anyone know what the #1 cause of death for kids is now? Gun violence. Yeah. And I mean, the school shootings for sure, but also domestically. Miscarriage was something I did not know until unfortunately I had a miscarriage myself, is that 1 in 3 people who have been pregnant have experienced a miscarriage. And I believe it's 1 in 4 or 1 in 5 pregnancies ends in a miscarriage. And some of them even before the woman realizes she's pregnant. So I had my miscarriage around 7 weeks. Still devastating because you're like, oh, I'm pregnant, yay, and then nope, now I'm not. And like it made me more pro-choice, which some people might think is weird, but it was like I saw the blob that it was when I was looking on the monitor, right? And like people expect folks to realize they're pregnant when it's only that far along, and they might not. I only knew because we were actively trying, right? So, but again, that's me, that's not other people. Other people have had opposite reactions. But again, because no one talks about miscarriage, right? No one knows this. And it's like this network of people that like when you finally start talking about, they're like, oh, I had 1, I had 2, I had a whole bunch, right? So it's really interesting to learn about. So we want statistics that are based on actual data. I mean, that seems like the bare minimum, but unfortunately, you're always going to have some researcher somewhere who fabricates their data. There was like one of my favorite studies that was so interesting. They showed people tall and skinny versus squat vases, and then like measured their body image. And the people who saw the tall and skinny vases felt worse about their body. I was like, this is so interesting. No, it was retracted. The guy just made up his data. Cool, great, right? So it not only like has ramifications for the field, but also like potentially cool findings that are just fun to talk about, right? You want your parameters and your variables to be well defined, right? If you're measuring something, you want to make sure you're using a good questionnaire or interview to do so. You want to make sure you're using statistics to actually apply to the argument being made. Sometimes people will just pull out random statistics that don't actually relate to what you're talking about. You want it measured well, but you don't want a false sense of precision, right? So like we could take pi out to infinite digits, and there are people who have hundreds of digits of pi memorized, right? 3.14159 is all I know. But like in everyday analyses, when we're thinking about circles, we really only probably need 3.14, right? Most of the time, we don't need to be that precise when we're doing something like architecture, right? This reminds me of a story. For a while at Wesleyan, we had hired someone from outside to help us do the type of assessments y'all did at the start of the semester for the department, right? Things about like how well are people doing, and you know, are we making our goals? And he was obsessed with looking at how far out the p-value went. Look at this p-value, how small it is. And in everyday sort of performance, or when you're publishing, you're just going to report whether p is less than 0.05, right? Or sometimes p is less than 0.001 will report. So no one really cares what your exact p-value is, right? That doesn't matter as much as what are the statistics actually found. We want to try to use representative samples, right? If I only use, let's say, the guys who take psych classes, right? It would not be representative of y'all as a whole. If I only use people who are first years, right? It wouldn't be representative of all the other years. So we need to think about trying to get people who represent all facets of what we're looking at. We also need to we need to look at data and make sure it's taking into account extraneous variables, or trying to rule them out if it's doing it in an experimental study. So this is one of the most interesting stats I found out like partway into the pandemic. One of the reasons why they list obesity as a risk factor for COVID is because of what happened during the swine flu, the H1N1 virus back in 2009. So they found a correlation then that people who were obese were more likely to like have bad symptoms and things along those lines. Well, someone went back and reanalyzed that data, and what they found is that what accounted for that taking longer and getting more severe symptoms is that people who were obese would go to their doctor and say, I think I have the swine flu, I'm sick. And the doctor would write them off or ignore them or say, it's just because you're fat, lose some weight, you'll feel better. And this unfortunately happens to people who are overweight and obese all the time within medicine because of the bias within the medical field. So in fact, when you accounted for how long it took them to get medical care, adequate medical care, this relationship disappears. So it's just because people who are obese are not believed when they say, I have a legitimate illness. And unfortunately, we see these same types of relationships for things like cancer. So doctors are less likely to offer cancer screenings to people who are overweight, including, you know, vital ones like cervical exams, prostate exams, So we want to be eliminating these extraneous variables, which are those factors that can affect research outcome, but you know, might not be of interest to the investigator, might not be known by them, right? Unfortunately, there's plenty of people who want to find that being overweight causes everything because it's a simple answer, right? And it also like fuels the diet industry, which is a multi-billion-dollar industry, right? And again, there are very good researchers out there who are not biased, and it's just not their fault. They were never taught to look for these relationships. So what you see in the media, the vast majority of the time, are descriptive statistics. These are things like the mean, the median, the range, even something like just the percentage of people who fall in each group. These are really common to be reported, pie charts and fun stuff like that, right? In scientific journals, however, these are often just the start of your results section. This is how you kick off the rest of the more complex statistics you're going to do. Descriptive statistics are how we take a lot of data and we summarize it, right? So some of these like Pew Research polls or ABC research polls, they do have thousands of people in the data set, right? So if you were trying to just sit there and talk through all that data, you can't, right? Doing descriptive statistics, how many people would vote this way, how many people would vote that way? Or, you know, sort of what's the mean approval rating for the president right now? You always hear that, right? Then you understand that data set pretty quickly. All right, so your book talks about the law of small numbers, and this is a judgmental bias that can occur when we mistakenly assume that what's true or characteristic for a small sample will generalize to a larger population. And this can be a real problem, particularly in brain research-based studies, but they're going to talk about some other examples in this video.
Common example, flipping a coin. Assuming the coin is fair, we know that the theoretical probability of flipping heads is 0.5 or 50%. However, that doesn't guarantee that if we flip a coin 10 times we'll get 5 heads. But we can be confident that as we continue flipping a coin indefinitely, the cumulative proportion of heads flipped should get closer and closer to 50%. Looking at this graphically helps to illustrate the concept. I just flipped a coin 20 times and these are the results. After each flip, we'll calculate the cumulative proportion of heads so far. So the first flip is tails, so our current proportion is 0 heads out of 1 flip, 0%. The second flip is also tails, so now it's 0 heads out of 2 flips, still 0% heads. Next flip is tails again, 0%. Then heads, now we have 1 heads out of 4 flips, 25% heads. Flip again and it's heads, 40%. Heads again, and we finally hit our theoretical probability of 50% for the first time. Let's keep going. This graph shows the observed probability approaching the theoretical probability. One common misconception, referred to as the gambler's fallacy, is that if the first 4 flips were tails, you're more likely to get heads on the next flip because the proportion is supposed to even out to 50% heads. This is not the case because each flip of a coin is an independent event. Its outcome is unaffected by all previous events. So if you start out with 4 tails in a row, it's not that you're more likely to get heads, it's just that in the grand scheme of things, 4 tails flips will get averaged with a huge number of flips that are expected to yield an even number of heads and tails, causing the proportion to approach 50% as the number of trials increases.
And obviously the only exception to that would be if you had some sort of weighted coin, right? And so this is like the Ocean's 11, Ocean's 12, Ocean's 13 thing where they have like weighted dice, and so therefore they can beat the house, right? So we do see variability in small samples. So this is the quality or fact of being changeable or showing variation, like the height of people, right? So if we looked at the height of folks in this class, we might find we sort of gather around one number or the other. But if there's 1 or 2 people who are, you know, really tall or really short, they're going to throw off our overall average. Whereas if we compare that to like the heights of people in the US population, right, it's going to be different. And I think I've mentioned this before, but one of the places where this becomes a real problem is in brain scan studies, because brain scans themselves are expensive. Yeah, I don't need an ad. I just want to see that. There we go. It's really pricey to do brain scan research, so people will often do maybe 20 people as their sample size. And then you have exactly like here, if we have, you know, someone who just happens to have a brain that's really different, then that's going to average in and kind of mess with the rest of the data more so than if we had 20,000 people in the brain scan study, right? So people worry that it's like the modern equivalent of phrenology, which was, if you're not familiar, where they thought they could like feel bumps on your head, and that said whether or not you were smart or had some sort of genetic things. And so basically they looked at resting state fMRI data in almost 500 people, and they weren't active. They were just kind of laying there. So they shouldn't have found any trends. And there was a lot of false positives. And one could be, you know, one reason for this could be is that people know they're being studied, right? So they're not resting like they would normally rest. Another could be just maybe something about being on an MRI makes your brain more active. You know that you're in some sort of situation. Couple other different articles here. I'll go ahead and open them in different tabs. So people trying to make brain research better. This is my favorite little anecdote. So people put a dead salmon, not a live fish, in an fMRI machine. I would not want to be the one who had to clean it out after that, right? And its brain lit up, even though it was dead, right? So something is going on with the machine itself. And so basically maybe the fMRI isn't quite sensitive enough or is oversensitive to things. And we need to be sort of careful about that. Again, I don't need ads, y'all. Thank you. So again, people just saying like, we really need to be aware of this. We need to look at it. So, and also both fMRIs and PET or PET scans aren't really measuring brain activity. They're measuring it indirectly. So they're either measuring blood flow in the case of fMRI, or they're measuring like chemicals as they move through the brain in PET scan, which is not the same as the actual neuronal activity, right? And so that we need to look at that. So these folks looked at 56 peer-reviewed published papers that had 90 fMRI experiments, and there were no consistent readings of these measures of brain function. So people have asked, and in fact, I've been in sessions at APA where people have asked, like, why don't we just use brain scans as the new lie detector? Well, it's for reasons like this. We don't know enough about the brain. Perhaps our methodology is not good enough to know about the brain at this point in time, right? And so we need to slow our roll, basically. We need to be doing these studies well and making sure that our instrumentation is as precise as possible, and that we're not just creating placebo effects by putting people in an MRI, right? Ooh, I'm in an MRI, something exciting is gonna happen, right? All right, another big thing that people mess up, and particularly the media tends to run with these things in wrong ways, is correlation versus causation. So correlation, as we talked about before when we looked at the Spurious Correlations website, is just an association, a relationship, but it certainly doesn't mean one thing causes the other. It can be totally random. It's just a mathematical description of how two variables relate to each other. After this, therefore, because of this, post hoc ego prompter hoc, is basically we tend to think, well, if two things occur together, one cause the other, right? I mean, you see this with superstitions, right? So the dance between pitcher and a batter in Major League Baseball, they both have these motions they go through because one time when they did it, they struck someone out or they got a grand slam, right? And so now they do them. And the really interesting thing is Skinner, who didn't put his baby in a box, did put pigeons in boxes and randomly reinforced them. And what he found is they developed superstitious behavior. They would keep doing whatever behavior they were doing when they were first reinforced, even though it was not influencing at all when that reward was coming. So people tend to think, well, because this happened, right, I gotta keep doing it. So this is a logical fallacy. It leads to the conclusion that because one thing follows another, the first causes the second. And again, can be, but not necessarily, right? And it could be, you know, a trickle-down effect. It could be maybe by the pitcher doing his ritual, he gets himself in the mindset where he does throw strikes more than this, right? But it's still not that like that is directly causing him to throw strikes, right? There's several intermediary steps there. So I've got a couple quick videos about correlation or causation here.
One of the most common problems we come across when communicating scientific findings is the confusion between correlation and causation. So here's a brief guide. Let's look at this graph. Now, along here, we've got the number of people wearing shorts. And up here, we've got the amount of ice cream being sold. And we observe...
I like that he's just using shorts instead of like the shark attacks or the murder statistic. Much more innocuous.
This strong relationship. Okay, this is a correlation or a link or an association. We're not assuming that wearing shorts causes you to buy ice cream or that buying ice cream makes people wear shorts. I think we can assume there's a common factor behind this relationship, for example, warm weather. Now, this is a very obvious example. But it's remarkable how often this basic confusion happens in science communication. Here's one of my favorite examples.
And I just want to take a second to talk about the phrase he just used there, science communication. This is something that modern scientists, whether they're natural scientists, social scientists, are really thinking more about. How do we effectively communicate our results so people don't get confused, so people don't misinterpret them, but that this vital data gets out there, especially when, you know, a lot of things are behind a paywall, as we see when we try to search for articles.
It starts with a study which was called Socio-Economic Position and the Risk of Brain Tumor, a Swedish national population-based cohort study. But we're going to see how the message changed from the paper to the press release to the press coverage. The abstract reported that we observed consistent associations between higher socio-economic position and higher risk of glioma. That is, richer people were diagnosed with more brain tumors, but they carefully only claim an association. The press release, however, reported that high levels of education are linked to heightened brain tumor risk, even though the study was not actually about education. And then we get to what...
And so how that probably happened is one of the proxies for socioeconomic status is your level of education, and interestingly, your mother's level of education is one of the best predictors of socioeconomic status.
The Daily Mirror put in their headline, "Why going to university increases the risk of getting a brain tumor." So this clearly implies that the university itself causes the increased risk. You know, maybe it's all that hard work damaging the brain. Of course, you may be able to think of two reasons why this association might just happen anyway. First of all, that richer people live longer, but the authors did adjust for age. But secondly, the authors pointed out that richer people tend to get better health care and therefore are more likely to get diagnosed with an illness. Causation is when...
So like, this is one of the problems with a lot of illnesses that are people like, where did this come from? How did this pop out of nowhere? A lot of times it just wasn't diagnosed previously. Like I saw something online that was like a really interesting way of describing it, where people were like, I never had autism before. And it's like, yes, we did. They were just like the really nice people that tended the sheep, right? Or did something like mathematical and didn't talk much, right? Like they've always existed. We just didn't have a name for it. And same thing here, that like, if you don't have good insurance to even go to the doctor, much less get a brain scan to look and see if you have a tumor, right? You might have one and they're just not finding it.
One thing directly influences another. And we can only confidently conclude that if we've done an experiment. For example, I might take all the people in the department and randomly allocate them to either wear shorts tomorrow or not, and see whether the shorts wearing group consumed more ice cream. But most of our studies are observational. We just look at people and measure things, and we can only then conclude that two factors may be linked or associated or correlated. We cannot say what would happen if we changed one factor. Of course, if we've got other supporting evidence, we might still be able to make some tentative causal claims, even from observational studies. So, how do we communicate correlation? Let's look at some phrases. When reporting a study, it's vital to know whether the claim is causation or correlation. Essentially, has an intervention been done or not? The Science Media Centre has suggested some phrases. So, for example, if you can only conclude correlation, you might say linked to or is associated with. If you can be confident about causation, you might say reduces or boosts, increases, can reduce, can boost. If it's sort of in between, maybe there's a good observational study with some strong supporting evidence, you might even say may reduce, may boost, at a push. What you don't want to do is what happened in the brain tumor study when the scientists clearly said is associated with, but the newspaper reported increases. So, you have to be clear whether the claim is correlation.
Right. And so for that reason, again, like as scientists, in our articles that we write, we always my co-authors and I check each other on this stuff all the time, right? Because it's very easy to slip into language like this increases that when it's correlational, right? And so you have to back yourself off and be like, okay, there's an association, there's a relationship. And so even PhDs mess this up sometimes. All right, and then this one. Another one kind of in a TED Talk format here.
Welcome. I came here today to warn you about the dangers of ice cream.
Everybody
You
loves
may
the
not
ice
be
cream
aware
one.
of this, but these innocent-looking cones full of sweetness are one of the major causes of drownings. And I've got the numbers to prove it. So if you plot a graph of the number of ice creams that are sold, and you compare it with the number of drownings, you can see there is clearly an upward trend. And I think it's very safe to conclude from this that we should ban ice cream, because it's very dangerous. Since you are all smart people, you've probably figured out there's something wrong with my example. What's really happening here is, of course, that there is an underlying factor, which is nice weather, you might have guessed it. And if the weather is nice, more people will go out swimming and unfortunately drown, and at the same time more people will buy ice cream. And it's not the ice cream that's causing the drownings. And here it's really easy to see that there is something wrong, but jumping to an incorrect conclusion about causality when you see a correlation is the most often made logical mistake. And today my goal is to make sure that in the future you can recognize this mistake, and I really hope you can avoid making it in the future for yourselves. And I'll do this by just giving some famous examples. And the first one is really rather innocent. The fact is that married men live longer than single men. If you look at the statistics, you see that this is really happening. And women's magazines, they like to conclude from this that marriage is very healthy for men because it makes them live longer. Well, a friend of mine, he likes to joke that marriage mainly makes life seem longer, but that's because his wife is... But so, can anyone guess what's going on here? Because there is a causal relation, but it's the other way around. The fact is that men who are healthy and rich and well educated and have a much higher life expectancy, these are the men that are much more likely to find a wife. That's the way women are. And the guys who have a very low life expectancy, so they're unhealthy and poor, they are not as likely to get married. So it's the high life expectancy that is causing the marriage, not the other way around. Well, and this, of course, it's not so serious. No one will get married just because he read this. So let's move on to a more serious example. It was also more serious research. In Nature was a study in 1999 that showed that young kids who sleep with the lights on, that they have a much higher probability of becoming short-sighted later in life. Well, and the researchers, they were smart and they wrote very careful that they had found a correlation, and they didn't know how the causal relation might work, but just to be sure they advised all parents to turn off the lights at night. And in the popular media, this became that bed lamps were night abuse, children's abuse, and that it was very bad if parents used lamps in the bedroom. And many parents were worried. I can imagine if this would have happened when my son was sleeping with the lights on, I would have felt really bad. But luckily, the article had to be corrected the next week. And maybe some of you can guess, if there are biologists in the audience, they know. Short-sightedness is genetic. And so it's parents who are short-sighted, and those are the parents who like to leave the light on in the bedroom. And they also are the parents who have short-sighted kids. So again, you know, a simple mistake, easy to make.
So you can see, like, some of these things have bigger ramifications in terms of telling people they're going to be destroying their children if they leave the lights on. I mean, you'll throw off your kid's sleep cycle, but other than that, not so much. Alrighty, I will see y'all on Friday.